If you're considering getting a VPN, a virtual private network that drives your internet connections through an encrypted tunnel, if you don't know which VPN to buy or which VPN to use, or even which one is best for you, check out VPN Ranks. That would be the best place to start, as they have all the comparisons, detailed reviews, and all the information you need. vpnranks.com. Hello everyone and welcome back to another video. Recently, whilst playing with my Commodore PET 1896, I came across a video and a blog talking about a piece of basic code, and the code that they were trying and running on their Commodore 64 was 10 print CRH $205.5 plus R&D brackets 1 go to 10, as I'm typing here. Now, I remember this code from, I think it was in the Commodore 64 manual, so this is 1982. It may have been printed in various magazines of the era as well. And what this does, or what it purports to do, is create a never-ending maze on a Commodore computer, or a basic computer anyway. So I thought, oh, I'll give it a go, I'll give it a try and see what happens. It's a very simple code, and as you can see, it types in very easily. You can do it in a few seconds, and it creates the most wonderful maze, or so I thought. Now, as you can see from the video above, that I'm running Vice Emulator on the Mac here, and the reason for that is quite simple. It's very easy to capture video from a Commodore PET on the Vice Emulator. Not quite so easy to capture video in real life. I need to create a user port video out, which I'm going to do at some point, but I haven't quite got around to it just yet. But anyway, back to the code. So what does the code do? Well, it's quite simple. It creates a random number, prints off 2 characters from the Commodore PET code from the key table, and prints them to screen. It's very simple. It does a left and a right I don't know what you call it, the left and the right. It's not a bracket, it's not a slash, because that's a different character on the Commodore. But it's a left and a right, whatever it is. So what does it do? Well, it prints the character 205.5. And why 0.5? Because there's no such thing as a 0.5. Well, it's all to do with integer basic. The 0.5 will become 205. And when it does a random to 206, the 206 will become, or the 206.5 will become 206. So it's printing 2 characters, one left and one right, and that is all that it does. And it creates the most wonderful pattern. But is it random? Is it a random pattern? I don't know. Is random actually random on a Commodore machine? There's no time of day, there's no clock. How does it know? Well, how does it generate a random number? Well, the fact of the matter is, there simply isn't a random number as such in a Commodore machine. All the random numbers are predefined to a certain degree, and what I mean by that is, if you run the R&D statement in BASIC on a Commodore machine and tell it to print that number, it will generate a number, or a point something, whatever that number is. If you run it again, it will give you another number. If you run it again, it will give you another number, and so on and so forth. So it is a completely different number every time. But is it? Well, no, it isn't. These are all predefined numbers, and it will print in a routine. So it will be an ever-present routine. What I mean by that is, if you run this code on another Commodore 64, it will print exactly the same number. But that makes no sense. Well, it kind of does, because every Commodore 64 is the same, every Commodore PET is the same, every Commodore machine is the same. regardless of what version of BASIC, regardless of any other parameters. The basic routine is always the same. So, but how does it run a generated, how does it create a generated maze? Well, very simply, it creates a random number the first time the random number command is written. So if you type RND into BASIC, it will create a number. If you type it again, it will create another number. But the first time that RND is run, it will always create the same number. So this pattern, if it's run on your Commodore 64 at home, it will start exactly the same way as it starts on my Commodore 64 or my Commodore PET. Now you can change the numbers slightly, the character, the CHR, and it will give you a different display, obviously, but it's still creating a random number, and it's still creating a character above and below. So it will always give you a recurring or repeating display. So it's quite simple in the way it does things. But the detail of the code is quite interesting. It's unique a little bit to Commodore 64 machines. If you try this on, say, an Apple II or any other machine, whatever machine it is, you will get a similar result, but not exactly the same. And there are various reasons for that. The way the characters are displayed and various other things. So, let's have a play with the command, see what we can find, and see what we can accomplish by messing about with this quite amazing single line of code. So as you can see, I'm running the Vice emulator here. What I wanted to do is try various Commodore machines and try the random number and see what it does, as well as create the maze. So as you can see, we have a number there. So if I reset the machine and do the same command, we should see the same number. Let's see if it works. 3.376. Let's try that again and see what happens. My typing skills are not the best, it's fair to say. 0.376. So every time you reset the machine, it will go back to the same number. But if I type RND1 again, ignore that. If I type RND again, it will, of course, create a new number. So let's try that once more. 0.376. So it's always the same number. So obviously this will carry on for any Commodore machine, but if I type it again, you get a different number. So this sequence must always follow on. Let's try it again. 0.9866 this time. Okay, so that's quite interesting. So the Commodore machine always starts with the same sequence of numbers. So if we print the maze in and run it, it will always generate, or will it always start in the same position? Will it give you a left or a right line? That should be interesting. We might try that and see what happens. So again, my typing skills are not the best. What I'm going to try and do now is type in a bit of Commodore 64 code into PET and see if it works. And this should generate a slightly different maze. Oh, I've got a syntax error. Let me try that again. Okay. My fat fingers are obviously pressing the keys in different ways. Okay, so this is quite a nice example of a maze. It's a different character set. Oh, I do like that. That looks nice. And you can see from looking at this, there is, or at least there seems to be, a clear way to get through the maze. If it is actually a maze, I'm not sure it is. It's just random lines, but let's call it a maze for the sake of argument. Okay, so let's try another bit of code, which I seem to be making a mess of typing yet again. Let's try that. There we go. So as you can see, it's a slightly more complicated code, but it's essentially doing the same thing. And this is creating a completely different visual effect anyway. the basic code isn't that much different. But that's quite pleasing. I do like that. But again, a very simple piece of code, very simple piece of basic, and it's quite stunning, really, quite therapeutic. I might print these off and sell them for £1,000 each. So the next stage, of course, would be to try this code on my PET, my Commodore 1896, which I've just restored. But I had a few problems, and Robin from 8-Bit Show and Tell was very kind. He answered some of my stupid questions. So what I'm going to do now is set the Commodore emulator to 1896 or some variation of that. It has to be a business model or 80 column, I think. Let me just see. So we're in 80 columns at the moment, and this is essentially the same behavior that my machine has. So there's the code for drawing the maze, but yet we have the M displayed. So why is this? Well, there's a very good reason for this. It's not what I thought it was, to be perfectly honest. Let's try a business model now and see what it does. I'm pasting this from the clipboard. Okay, so for a 4032, it works fine. So let's do another 80 column and try and see what this does. Run. Okay, so the 80 column machines obviously are not displaying the maze properly. So let's try my exact model. Paste that in there. And yep, there we go. So the 80 column machines are not generating the correct PET graphic code or graphic display. So why is that? Well, the simple fact is it's because it's using upper and lower case on the business machines, not the graphic case. But if you put that little poke command in there, the CRH142 rather, that will change the graphic mode, or change from the business mode into graphic mode, and allow you to run the graphic character set, so then the maze will work properly on an 80 column machine. Now I'd forgotten, I mean I was thinking it was all kind of problems with the character ROM or the edit ROM or something, but I mentioned I reached out to Robin at 8-Bit Show and Tell, and Robin was very kind and very quickly got back to me and said no, it's because the machine doesn't have or isn't naturally in the graphic mode because it uses the 80 column business keyboard. So there we go. So as long as you've got an 80 column machine, yes, you can run the maze program in very simple basic, but you do have to change it into graphic mode rather than upper and lower case, which it's naturally in. So obviously, does this code work for the Commodore 64? Well, of course it does. I mean, the examples I'm using are from the Commodore 64 manual, and the book that was been released. There is a whole book that is called 10 Print Character $205.5 R&D 1 GOTO 10. It's available in paperback, and it tells you all about the origins of this code, how it works, the features of the random command R&D, the character set, the PET set, and what have you, and goes on to talk about repeating code and all kinds of things in modern society today. It's very good. It's very, very good. I've read parts of the book. I haven't read all of it, I must admit, but it's very good. So on a Commodore 64, you can see that it displays just fine. Perhaps not as clean as the Commodore PET version. To be honest, I do prefer the PET version, but there you go. So there you go, there's the code on the Commodore 64. Nothing to see here. It works as we would expect it to work, and it works fine. So let's move on to another one of Commodore's machines, the slightly less popular and less impressive for all the wrong reasons, the Commodore Plus 4 or 364 or whatever else you want to call it, 264 or whatever it is. I suppose a 116 is essentially the same machine as is the C16. So we'll type the same code in as we did before, and I have no doubt it will run just the same, even though it's basic 3.5. There we go. Now that is a cleaner display than the Commodore 64. Very PET-like, although there is a slight gap between some of the characters, but yeah, that works fine. Yeah, it's quite pleasant. That's quite nice. I suppose the only one left to try, well, while we're in Commodore land, we better try the C128 and the D128. It's the same machine. And we'll try it in 128 modes. This is Commodore Basic, whatever it was it 7, version 7. There's not a huge difference between all the Commodore Basic versions. The higher the number, basically the more disk features it had, and lots of bugs were fixed. So there we go, it's very Commodore 64-like in the way it works. Yep, that seems to work just fine. And last but not least, by any stretch of the imagination, we have the Commodore VIC-20. As you can see, I made a mess of typing it in, but there we go. That's the code running, the maze program on a VIC-20. Quite nice. See, it lifts up. It seems to lift up three lines and then prints the code. I'm sure there's a very good reason for that, but I don't know what it is, if I'm perfectly honest. Something to do with the VIC chip, I guess. The display on the VIC-20 is 20 column, so that might have something to do with it. But the code works fine. So what was the purpose of all this? Well, it was purely to try this code, which I'd seen as a kid all those years ago. I'm sure I typed it in as a 10-year-old in my Commodore 64, when I got bored with the handful of cassettes that came with it. And it's quite a simple code. I did like quite concise code as a kid, because I was too lazy to type it all in, and 9 times out of 10 it didn't work. So if I saw a line of code that was only a few lines long, I was all over it. So bouncing balls, flashing screen colours, random SID tunes, and mazes were right up my street. And to be perfectly honest, I'm not that much different now. A simple code, it's very elegant, very neat. I do like it. But I did try this on an emulator, as you can see here. But when I tried it on my Commodore PET, my 1896, I was quite disappointed that it didn't run. I'm quite intrigued, actually. So that's when I started having a quick look to try and find why, and I couldn't instantly find a reason why. I was thinking it was the character ROM or the edit ROM, which was something to do with the graphic display, which seemed obvious to me. But I'd forgotten that you could kick the 80-column machine into 40-column machine mode, or at least pseudo 40-column machine mode, by running a print character command. That's when I reached out to Robin at 8-Bit Show and Tell, who was kind enough to remind me of the fact that I'd forgotten to type in the character command. And there you go, you can display things as they should be displayed. Now, years ago, there used to be programs for the Commodore PET to switch it from 80-column into 40-column. And I guess these programs were slight variations of that print command, but I never really looked at them. So what I might do in some spare time is load up some of these commands and see what's actually in the code, because I don't think it's actually generally possible to degrade an 80-column machine to 40-column. It sort of squashes the picture into the center of the screen, so there might be some clever coding involved, I don't know, but that's for another day. Now, if you want to read more about 10 print character 205.5 plus R&D open bracket 1 close bracket, there is a book by Nick Montfort, I think it is. Actually, it's Montfort rather, Nick Montfort, and various authors. There are 10 authors, I believe, who have written this book. Mark Sample, John Bell, Jeremy Douglas, various other people. It is an interesting read. It's surprisingly more interesting than you may think. So it's well worth having a look at this book and give it a go. It goes into great detail about how this code works, how the Commodore 64 works, and the effects of random code that's had on art, weaving, and history in general, really. So it's a very good book. It's very far-reaching and well worth a read. Anyway, that's it from me. Have a very pleasant weekend, and I'll see you in the next video. Goodbye for now.